In this section, we're going to explore the basics of using the shell. You'll learn how to move around the command line effectively and efficiently. We'll also use a text editor, VI, which you'll spend a lot of time in as an administrator, and we'll write a basic shell script. So let's get started directly on the shell. First, we need to learn how to move around the file system. You want to learn to list files with the ls command. ls lists the files in your current directory. To make a new directory, you type make dir and then the name of your directory. You can change into that directory with the cd command, change directory. We will cover the file system in more detail in a later lesson, but you should know that it's a hierarchical structure. If I type the pwd command, it shows me where I am in the hierarchy. The shortcut dot, just a single period, refers to the current directory, in this case /home, /vagrant, /newdir. The shortcut dot dot refers to the parent directory, or in this case /home, /vagrant. So in order to move to the parent directory, I type cd dot dot. If I type ls again, I see the files I saw initially as well as my new directory. I can type to a new path, cd space /temp, and in order to go back to my home directory, I have a number of options. I can type cd, which is just a shortcut to take you to your home directory. You can type cd tilde, which is also the shortcut to the current user's home directory. Or I could type cd minus, which takes you to the last directory you were in. Let's look at the shell prompt itself. We have the username, in this case vagrant, and we have the host name. In this case, the host name is localhost. This will vary depending on the system you're in. The next section is the directory you're currently in. Tilde represents the user's home directory, and notice that when I was in temp, shell prompt showed temp instead of tilde. So the prompt changes as you move about the file system. The bash shell prompt is highly configurable, and people like to make all sorts of adjustments to suit their needs. Let's learn about how to edit some commands. On the bash shell prompt, the hash character indicates a comment. The $sign at the end of the prompt indicates that I'm a regular user ready to type commands. By convention, when you become the root user, which is a highly privileged user in Linux, the prompt changes to a hash sign to indicate that you're root and you should be more careful. We'll learn more about user privileges in a later lesson. In general, you should always log into the system with your normal account, and if you need to execute privilege commands, use the sudo keyword. We can run a command just by typing it, and of course if we want to run multiple commands, we can separate them with a semicolon. For instance, we could list files, and then we could change directories in a single line. Notice that the files listed out, and then my directory changes changed. I can go back with cd minus. I can put a process in the background with the ampersand character. For instance, I could open Vim, a text editor, but I could put it in the background so it's running not in my current context. So in this case, Vim opened, it's running with process ID 1762, but we're still in the shell. We'll learn more about how to control processes and what a process ID is later. If I wish to now access the program that I started in the background, I can type FG for foreground. Now I'm in the Vim text editor. We're going to cover Vim in just a few minutes. Something that will really help you become an efficient system administrator is using shortcuts on the command line. Let's learn a few shortcuts that will help us move around the command line quickly. We can use the echo command to echo output to the terminal. For instance, echo, the quick fox jumps over the lazy dog. This just echoes that output to the screen. Now if I hit the up arrow, I can recall that previous command. I can use Alt-B to move back a word, and I can use Alt-F to move forward words. You can use Control-A to quickly move to the beginning of the line. You can use Control-E to quickly move to the end of the line. If I use Control-U, it erases all of the text that I just typed and puts it in my paste board. I can paste it back with Control-Y. We'll have a handy list of shortcuts for reference available with the lesson materials. Now we're going to learn about a concept that is essential to understand for a Linux or a Unix system administrator, and that's pipes and redirection. Pipes and redirection is a concept that has given the Linux command line some of its most powerful features. So, for example, the ps command shows us the running processes on the system. I can pass it some arguments like ps, ax, to list processes in more detail. Don't worry if you don't understand the ps command, its arguments, or the output. That's not the focus here. If I type ps, aux, and I use a greater than symbol, that will take the text output from the ps command and it'll redirect it. So for instance, I could redirect it to a new file called processes. Now the content from that command has been captured in this file called processes. I can see the type of file that it is by typing simply the file command and giving it whichever file I want as its input. For instance, file processes shows me that it's just ASCII text. Now I can search within that file and I could perform operations on the text within that file. For instance, I can use the grep command and search for a specific keyword within the processes file. In this case, it found that there was a process in the list called bash within that text file. We're going to learn about grep and its purpose in a little more detail later on. You should also be aware that you can use tab completion on the command line. So when I start typing something, for instance gr for grep, I can hit tab and it completes other possible commands for me. If there's only a single option, it will finish it completely. For instance, if I continue to type grep bash and I type pr for processes, if I hit tab, it automatically expands the file name. This will save you a lot of typing. Now comes piping. Piping allows you to string a series of commands together using the output from one command as the input to the next command. For example, I can use the same command we did before, ps aux, and then the pipe key, which is the vertical bar usually situated above the return key, and I can pipe it to grep for some specific command like bash. So this is running the process list and searching for very specific output. Using the pipe, you can connect any two commands together, or you can string many pipes together to perform very complex operations. For instance, I could echo a brief statement in quotes, and I could use greater than to append it to the processes file I already captured. Now if I use the tail command to look at just the end of the processes file, I can see a brief statement as the final line of input. Next, let's learn about variables and quoting variables. To assign something to a variable, you simply type the name of a variable, the equal sign, and then whatever you want that variable to contain. For instance, I'll assign the quick brown fox to the text variable. I can view the variable contents with the echo command. Now, importantly, I can also capture the output of a command into a variable. For instance, if my variable name is ls_text, I can capture the contents of an ls command into that variable using this syntax. So let's just make sure we understand this. LSText is the name of the variable. Equal sign indicates that we would wish to assign some contents to it. And then we have $ with an open and closed parenthesis and the command in between them. This will take the output from ls-l and assign it to the LSText variable. Now look what happens when I try to echo the contents of this variable. It's the same contents that we would expect from the ls-l command, but it's all glued together with no line breaks. This is due to how the shell has interpreted this variable. If I instead use double quotes to echo the output of this command, I get the exact format that I expect. Now note that if I use single quotes rather than double quotes, I get the literal LSText variable output. So quotes are important to the shell. When you use a single quote, the variables are not interpolated by the shell. When you use a double quote, the variables are interpolated by the shell. We should also distinguish between environment variables and regular variables. An environment variable is available to all processes on the system. You can use the command print env to view all environment variables. We see several environment variables here that are set automatically by the system. You can use the export command to make shell variables available to sub-processes on the system. For instance, in order to capture an environment variable, we type export and then the name of the variable. By convention, environment variables are always uppercase. So if we wanted to export ls text, we would probably name it uppercase, and we could use the same command we used before. Now the ls text variable is available to any sub-processes that I start with in my shell. To remove a variable you've already created, you can use the unset command. You type unset and the name of the variable without the $, and then that variable is removed. If you try to echo it, it has no contents. Next up is learning about filtering. Linux has a powerful variety of filtering commands available at your disposal. We'll use the cat command to cat out the etc passwd file. This file contains all of the user accounts on the system. We don't need to parse through each line of the file now, but we should just note that each field is separated, otherwise known as delimited, by a colon. The first field is the username, the last field is the shell. Just for example, we don't need to go through each field, but look at how we can manipulate this file using filtering commands. I can use the command cut to pick out specific fields in the output. For instance, if I wanted just the username field, I can use cut -f1 -d, and then in single quotes a colon, and then I pass the name of the file to print out only the first field of the file. So just to make sure we're clear, -f is the field, we want the first field, -d is the delimiter, in this case the colon. You can learn about all of the arguments and flags available to the various commands using the man pages. We can continue to use pipes and redirection to add on to this command. For instance, I can repeat the previous command by pressing the up arrow. I can use the pipe character to pipe this output into the sort command. Now the output is sorted alphabetically. I can continue this by adding another pipe and piping it to unique. Unique will remove any duplicates that are in the output. In this case, it actually didn't do much since there were no duplicates. Finally, I could pipe the output yet again to filter out for just, say, the first 5 results. I could do that with pipe to head -5. Now we're only printing out the first 5. Similarly, I can use tail -5 to print out just the last 5. Filtering commands are very powerful and you'll find yourself using them regularly. Next, we can look at shell history. Shell history will help you recall previous commands that you've already typed on the terminal. It becomes very useful because you'll find that commands are often repetitive. History is stored in your home directory in the file .bash history, which we'll look at right now with the less command. This shows all of the commands that I've typed on this terminal. I use Q to quit out of the less command. You can access the shell history interactively in the terminal with the up arrow and the down arrow. Notice as I push up and down, I parse through the commands that we've already been typing. You can type the history command to quickly, at a glimpse, see all of your shell command history. We notice that there is a number in advance of each command. This lets me quickly access a command in my history. For instance, if I wanted to access the file processes command in my history quickly, I could use exclamation point, often called just simply a bang, and then the number, 499. That runs the same command again. I'd like to encourage you to become familiar with the Control-R search history function of the bash shell. If you type Control-R, your prompt changes and it says reverse I search. What this means is that it's going to search in your history for case-insensitive content of whatever you type. Let's go back and type fox. We see when in the past I assigned text equal the quick brown fox in the variable assignment example. If I hit Control-R again, it continues to search in my history. This is a really quick and efficient way to access your shell command history. Now if I just press enter, it executes that command again. If you become proficient at using Control-R, you'll find that moving around the bash shell is very quick and efficient. I can execute the last command that I just typed with the bang bang shortcut. I can also refer to just the last argument on the command line. For example, if I type ls-l processes, that shows me a long detailed listing of the processes file. Now I can, as a shortcut, type file and then bang $sign to refer to the last argument on the previous command. This runs the command file processes. I hope that this brief introduction to Linux hotkeys was useful for you.